So we're reviewing, getting ready for the exam number one, which is Thursday. One of the important things I think I told you guys, if you check the chapter 7 homework, it's actually due after exam number one, after this coming Thursday, rather. It's due over the weekend sometime. You can look at the due date yourself. And I told you last week that part of that was because I wanted to take some of the pressure off because we had a whole bunch of crud that's due this week. Okay, so I want to give you time, but there's another reason for that. And that other reason why I'm allowing you extra time for the chapter 7 homework is because chapter 7, which is factoring, is incredibly important, and it's really worthwhile, even if you don't get it for the chapter 7 or exam number 1, I'm sorry, even if you don't get it for that, it's absolutely critical that you get it for the rest of this semester. In particular, the next chapter we're going to cover, which is right after chapter 7, means chapter 8. Okay, I would say 95% of chapter 8 requires that you can factor and factor quickly. Okay, so that's another reason. One is I want to take some pressure off in terms of all the crud that was due this week. Two, though, I wanted to give you guys time to really work on it and really learn your factoring. Okay, you just have no clue how important it's going to be, not just in our next chapter, but it's going to keep popping up throughout the rest of this course and in all of your future courses. So it's really, really, really critical that you work on it, and be able to do it rapidly, fast. Okay. All right. The other thing, reminder, and then I'm going to erase the board a little bit. Our exam is Thursday. I know our class doesn't start till 6:35. No problem. I'm going to be there at 6. Okay. If you want to come in early and have me help you a little bit, great. Okay. Ask the last second questions. If you want to start early, that's okay too. Okay. That's fine. Once you're done, turn it into me. It's okay to leave. Warning, if you turn it into me to leave, turn it in, turn around, walk out, and then come back and go, oh, I forgot to do problem 7. Sorry, too bad. Once it's turned in, it's turned in. But you're welcome to start early, and then when you're done, leave early. I don't know what Thursday night football is, if it's any good or not. I don't know. Okay. Also, last thing before I erase all of this, on Canvas, I put some review videos from last semester. Okay, other students asking me questions. You may find those helpful, you may not, but they're open and they're accessible on Canvas right now. Some older videos. They're in the exam number 1 module. So if you want to go there and find some videos and that maybe give you a little bit of extra help, that's cool. Okay. One last thing before we start doing problems. Maybe I shouldn't record this. I'm in trouble. Okay. Tonight and tomorrow night are totally optional nights. I'm reviewing anything you guys ask me. Okay, I don't have a whole lot planned. I have a little bit planned, but not a whole lot. So if you feel really good about Thursday's exam, cool. You don't have to show up. You can quit early tonight. You can quit. You don't even have to show up tomorrow night. That's up to you. Okay, you make the decision. If tomorrow night you go, okay, I know all this stuff. You've been here a half an hour tomorrow night, and you go, I quit. That's it. I'm done. I'm ready. Great. Whatever. Tonight and tomorrow night, attendance is optional. You do not have to show up. I am not going to take roll tonight or tomorrow night. So that's completely up to you. I am going to teach nothing new, just review a bunch of stuff for the exam, but that's up to you. Okay. having done all that, and it's been recorded. Okay, so solving. The first step was make it equal 0. Hopefully, we had some debate the other day of why didn't we move the 3x squared over here with the 12? Okay, and my answer to you the other night was you could, it's a legitimate step, but I have found that students generally make fewer mistakes if they keep the coefficient of the x squared term, in this case 3, positive. So leave the 3x squared here, it's positive, move the 12 over with it. Okay, we're going to do the same thing there. I'm going to leave the 6x squared here and move the x and the 2 over here with it, because I want my x squared term, the coefficient of the x squared term, to be positive. Not required, just safer. But anyway, back to this. All right, we have a checklist of factoring. We have things called grouping and trinomial easy and trinomial hard, okay, and dose and all these things. But the number one type of factoring you always try to do is, what do they have in common? Okay, what do they have in common, if any? I mean, they may or may not, we don't know. But in this case, they both have a 3. 3 goes into both of these, and x goes into both of these. So we divide out a 3x, and that leaves me x minus 4 equals 0. Okay, I'm going to erase this other problem. I'll put it back up in a minute. Okay, once you factored it, okay, then you split it up. I said split it up and solve the babies. So you have either 3x equals 0 or x minus 4 equals 0. Remember, factoring means to rewrite as multiplication. So this is 3x multiplied by x minus 4. Okay, so we split it up, and then we attempt to solve each one. The first one is easy. Divide both sides by 3. We get x is 0. Second one is easy. Add 4. We get x is 4. And so we get, for our solution set, 0 and 4. And it doesn't matter what order you put them in. You could say 4, 0, 0, 4. Those are your answers. Is that okay for problem number 1? Okay, we factored in common. Okay, moving over to problem number 2. Okay, again, it's got to equal 0. So I'm going to take x away from both sides and take 2 from both sides. It looks messy up there, but if I do that, I have 6x squared minus x minus 2 equals 0. Okay, now again, I run through that checklist. Do they have anything in common? 2. Well, wait. 2 goes into 6. 2 goes into 2. But does 2 go into the invisible 1? Nope. So they don't have anything in common. Okay. Common means all of them share something. All of them share. So it's dose means 2 terms, not 2 terms. Grouping means 4 terms. There's only 3. So this must be a trinomial. To do a trinomial, we do the AC bit. Okay. So we go off to our scratch paper and we get AC is negative 12. We run through our times tables list real quick. Okay. What times what equals negative 12, but adds to the implied, here it is, negative 1. So I would say negative 4 times 3. Negative 4 times 3 makes negative 12. and negative 4 plus 3 makes negative 1, which is what we had here. So we take those two numbers and we say 6x squared. It doesn't matter which ones you use. I'm going to say minus 4x plus 3x minus 2. You may not like that. You may want to move the 4 and the 3 around. That's okay. We'll get the same answer in the end. Okay, so what we've done is the math theory of it is we've taken the minus 1x and we've written it that way. It's still worth minus 1. It just looks weird. Okay. Factor out a 2x out of, oh, I'm sorry. I'm skipping a step. Okay. So I always throw parentheses around the first two, leave the plus sign in the middle, parentheses around the last two. Okay. What can I factor out of the first group? Take out a 2 and an x, leaving 3x minus 2. Plus, what can I factor out of the second group? Nothing. But this is a trick question, and I wanted to do this to remind us, you can always factor out a 1 if you need to. Okay, 1 is there. 99% of the time, it doesn't do us any good. But if your answer is, I can't factor anything else out, the answer is, I could have factored a 1. So we have 3x minus 2 equals 0. Our check is, this is the grouping method, AC plus grouping, if those two are exactly the same. They are. So Foster says, bring it out front. So we have 3x plus 2 times 2x plus 1 equals 0. Wait, we're not even done. Not even close. All we've done is factor this. Now, just like here, after we factored it, then we split it up into the babies. That's what I called it. So I'm going to come over here and say 3x plus 2 equals 0, or 2x plus 1 equals 0. Either the first quantity is worth 0, or the second quantity is worth 0. This times this. So using my math, take away 2, 3x is negative 2, x is negative 2/3 because I divided by 3. Over here, 2x is negative 1, take away 1 from both sides. Divide, x is negative 1/2. So my solution set is negative 2/3 and negative 1/2. And pretty much, if you can do those two problems, then you can do the solving on exam 1.
Hey, Professor, shouldn't it be positive 2/3? Because that was originally 3x minus 2?
Yeah, it should be, but apparently I'm an idiot. How I wrote this here, I screwed up. So in your notes, and it's on the video forevermore, that should have been a minus. That should have been a minus. So that's a plus, that's a plus, that's a plus. Thank you. See what happens if you don't use it, you lose it. For 4 days this weekend, I haven't done much math. Actually, I have. I've been helping my granddaughter do her 4th grade Common Core math. That's got nothing to do with this. Thank you. Okay. Sorry, didn't mean to screw that up for you. Hope it didn't ruin everything. Questions on any of this? Number 1, number 2. Okay, I need to erase to make room for the problem I had up here originally. Everybody got this? Okay. So I think what I wrote was this. I said, suppose f of x is a function. Remember, that's how you say it, f of x, and it equals this, okay? X squared plus 2x plus 1. So some function does that. Remember, a function was defined as a rule that changes the value of something, something you plug in. So part A was find f of -3. So all we're asking you to do is plug in -3. So that would look like -3 squared plus 2 times -3 plus 1. Again, notice my use of parentheses. Students don't like to use parentheses, and it kind of makes mistakes, especially when you're using calculators. Because if you put -3 on your calculator and then you tried to square it or whatever your calculator does, you're going to get -9. Because you're only squaring the 3, not the negative. If you want to square -3, then you have to use your parenthesis on your calculator, whatever your feature is, and get +9. So this is 9 plus -6 plus 1. Okay, 9 and -6 is 3 plus 1. Final answer is 4. And that you're just doing arithmetic, so just circle the problem. You're done. It's okay. Now, I did that problem as a review of functions, but also to remind you when we say f of -3 or f of 5 or f of whatever, it literally means plug that in place of x in the rule. That's what we did. We took -3 and stuck it in place of the x. Okay, but then I asked this question. I said, if f of a equals 11, find value of a. And this is a little bit different. Look what this says. It says if you plug in a, the answer is worth 11. It doesn't say plug in 11. If I wanted you to plug in 11, I'd say f of 11. That would be plug in 11. I didn't say that. I said if you plug in a, so that would be f of a would be a squared plus 2a plus 1. If f of a is that, because we plugged a everywhere there was an x. But then we said, whoa, wait a minute, the answer is 11. When you plug in a, the answer is worth 11. So this is worth 11. Okay. What we're doing now is trying to solve this problem. Because it said find the value of a, so that when I plug in a, the answer is 11. I don't know what it is. We'll see. We'll get it in a second. Well, check that out. That's a quadratic equation. That's what we've been studying in the last part of chapter 7. Okay, it's got to equal 0. So if we just think of this not as a function problem, but we just think of it as an algebra problem. Okay, take away 11 from both sides. We get, where's my glare? Okay, I can go down. A squared plus 2a minus 10 equals 0. Okay. I'm rewriting it. Okay. We're going to use the AC, but this is a shortcut. This is another reason I picked this problem, is because this is still a trinomial, okay? But it's a shortcut trinomial. It's what I call an easy trinomial because there's a 1 here. And I'll show you how. If we still use AC is -10, oops. I screwed up. It can't work. Damn it, damn it, damn it. Can't work. I screwed up. My notes, where were my notes? 11, -12. This has to be 3A. Shit. I mean, darn it. Crap. Sorry, I just really messed this up. That has to be a 3A. Yeah, damn it. Because we want to say, okay, if AC is -10, then we want to say 5 times -2. 5 times -2 makes -10, but 5 plus -2 makes +3. So make sure you get that in your notes. You can say Foster screwed up again. I did. Okay, what I was focusing on and not thinking clearly is I wanted to point out that because the coefficient is a 1 out here, we can shortcut this by just using the 5 and -2. We don't have to go through all that grouping stuff. Well, so x minus 5 equals 0, or x plus 2 equals 0. Finish, x equals 5, x equals -2, solution set 5 and -2. Okay, and I really choked on this problem. I apologize because I got that middle term wrong. And that kind of just ruined everything. But I wanted to show you easy trinomials and how cool it was, and you, okay, whatever. Oh well. Questions on that?
We're supposed to multiply the 11 by, you're supposed to square it, and then 3 by the 11.
No. You don't use the AC until it equals 0. The first step was make it equal 0, then factor it. When you're trying to solve a quadratic equation, okay, when you're trying to solve what it's called a quadratic equation, which is ax squared plus bx plus c equals 0. Basically, somebody with a power of 2 is basically what it's saying. First, I said it must equal 0, and it must be in order of exponents. So it's got to have the squared first, then the x, then the constant. So that's what I did here. A squared plus 3a plus 1 equaled 11. I said it can't equal 11. I need to make it equal 0. Okay, so I took 11 away. Okay, then secondly, I said to factor completely. Now, this is where you use your factoring. Do they have something in common? Is it a dose? Is it a trinomial? Or is it grouping? And if it's a trinomial, that's when you use the AC stuff. But look at these steps that I did way before then. Okay, it must equal 0. I got to get it in order with the highest exponent first, and then I run through this. You don't do AC at the very beginning. You do AC in the middle of this problem somehow, if that's the way you factored it. Okay, so these are choices that you use. You won't, maybe you don't use trinomial. Maybe on another problem you use dose. Then you don't have to worry about the AC. All right, the third step, okay, was to split it up, okay, and solve the babies. That's what I said, solve the babies. So that's what I did here. After I factored it, then I split it up. I said, that's one baby, that's another baby. Solved each one, and then I put it all in solution set. So fourth was solution set answers. So I'm not sure if I answered your question or not, but you don't use AC at this step. It has to equal 0 first. And then you sit there and analyze. You go, okay, after it equals 0, now which type of factoring do I use? If you decide to use trinomial factoring, then you're right. Then you go to the AC. But notice you got to run through the steps in order first.
Because I thought you had like f of a equals 11.
Yeah.
Professor,
Yeah.
on the baby problem, you put x plus 2, and then on the very bottom, you minus it, and you gotta have some facility to do something. It's supposed to be positive or negative.
It gives you positive, it gives you negative. What did I write? Okay, look, I had this. Okay, for everybody, let's go back and answer 3 or 4 questions at once. So that was f of a was a squared plus 3a plus 1, but they told me that f of a was worth 11. Okay, that's what the problem said. So you notice then I said, this is the problem we want to solve. This is a squared plus 3a plus 1 equals 11. We solve that problem, we'll find a. So then I took 11 away from both sides. Okay, and that got me a squared plus 5a plus 5a. Jesus, I'm having trouble with that. Plus 3a minus 10 equals 0. Made it equal 0. Now I decide which type of factoring do I use. They don't have anything in common. There's nobody that goes into all of them. It's not a dose, because dose means 2 things. It's not grouping, because grouping means 4 things. So the only thing it must be is a trinomial. Okay. So so what we write is the AC over here was -10, which means we use -5 times 3 times 2. Why am I having such a hard time tonight? Okay, so this breaks down to x minus 5. Oh, I see what you're saying. X plus 2 equals 0. You use, I kind of did this differently. Okay, a minus 5. Maybe I should just go to bed. Okay, because you're factoring with a. So the shortcut trick that I seem to be having a lot of trouble with is you use exactly these same numbers, a minus 5, a plus 2 equals 0. The only time you can use that shortcut trick in solving or in factoring is when there's a 1.
I think
So
they're
then-
confused with,
What?
I think you got, isn't it plus 5? Because 3a is a positive number.
Huh. Hmm.
I think that's what they're confused with.
Oh. So this is plus 5 minus 2. Is that what the comment was?
I think so.
Yes, I screwed this up because this equals plus 3. Maybe I should just go on to something else that I might be able to get right. 2 plus 2 is 4. I can do that. Okay. Maybe I should go back to 4th grade math. Sorry. You're right. Okay. And I have no excuses now. I'm not focused. I don't know why. So you're right. It's 5 times negative 2 is negative 10, and 5 plus negative 2 is 3. So you take the a plus the 5 and the a minus the 2, that's the shortcut. So you take a plus 5 equals 0, or a minus 2 equals 0. Solve each one. A is negative 5, take away 5. A is positive 2, solution set, negative 5, positive 2. So there's a question about was my answer to positive or negative? I was wrong the first time. Okay. No excuses. Is this okay with everyone now? So there's 2 questions on this. When do you use AC? You don't use it when there's an 11 there. You can only use it after you make it equal 0. Okay, you can only use the AC after it's worth 0. And then I tried to show this stupid shortcut and I just blew it 50 different ways here, but 5 times negative 2, so positive 5 minus 2, when you solve it, you get your solutions of negative 5 and 2. So how else can I confuse you now that I've totally ruined this problem? Any questions?
Just to like go back. So if the
Okay.
numbers is within the parentheses of the function, that's X. And then,
Well,
If-
wait a minute. If the number, you mean like right here?
oh, so like back to like the word problem. So like F parentheses -3, you just put -3 into the X.
Right.
Okay.
Yeah,
And
but
then
this
if
was,
it says,
I'm listening.
so if it says if f of A is 11, find the value of A, that's plug it in the equal sign.
Plug
Yeah.
it in A and say it equals 11, because that's what it said.
Okay.
Okay. I'm not sure I would worry about that. If that's a question, it's one question on the multiple choice. And that's 1 point. So I'm not sure I would lose too much sleep over this example. If it's a question, it's a multiple choice question. And I will make sure that if we have it again in the future, that I give you more examples that I get right and don't screw you over. Okay, can I erase all my mistakes and move forward? All right. The quiz that was due last night, most everybody did wonderful on it. Your newest scores are up on my website. You know, that funky, weird one you have to go to. The newest scores, which contain the chapter 6 homework and the second part of the chapter 5-6 quiz. They're all up. Your grades are due up to date right now. But there were 3 problems that as a class, just in general, we didn't do very well on. So I want to talk about those, okay? The first problem that people had was this problem. And this was also on last Thursday's in-class quiz. This was on the quiz we took in class. Okay, and this was on then the mom quiz you took over the weekend. So there's number 1. This is number 2, which is and I'll put number 3 up. I'll put number 3 here and then I'll have to erase it and redo it. But number 3 was solve by graphing, which, who asked me this last Thursday in class right before the test? I think it was Emma, whatever. Y equals negative 2/3 x plus 6 and x plus 3y equals 12. So let's take a few minutes. I'm going to have to erase this problem, make sure I have enough room, but I'll put it back up in a few minutes. So work on these, see if you can figure out how to get it right or not. Okay, so number 1 here, it says squared, and it means 3x plus 4 multiplied by itself. There are 2 ways this can be done. Traditionally, people write this as 3x plus 4 times 3x plus 4, and then they start distributing. And I looked at some of you guys' work and it was kind of weird, okay? But I guess I can't blame you too much because you have me as a teacher, so I keep screwing up everywhere. But what you do is you distribute the 3x to here and to here. So 3x times 3x is 9x squared. 3x times 4 is plus 12x. So that's where you take the 3x and you distribute it to everybody in the back. But you also then take the 4 and distribute it to everybody in the back. Okay, so you have 4 times 3x is 12x, and 4 times 4 is 16. And then you notice, you go, oh, look, there are like terms. 12 and 12 is 24, so this becomes 9x squared plus 24x plus, 16. And this is your correct answer. And that's the traditional way that multiplying binomials is taught. Write them side by side and then distribute the first term to everybody in the back parenthesis, write it down, and then distribute the second one to everybody in the back parenthesis, and then look for like terms. Okay, that's the traditional way. The other way I tried to show you guys was something called a box or a matrix method, where you write 3x and 4, 3x and 4, and then you just start multiplying. 3x times 3x here is 9x squared. 3x times 4 is 12x. 4 times 3x is also 12x. And 4 times 4 is 16. And when you add the like terms that are here, you're still going to end up with that answer. You have 9x squared, 24x, 16. Same answer up here. So that's number one. Okay. What you can't do. Number one, same problem, 3x plus 4 squared. You cannot say this is 3x squared plus 4 squared. You cannot distribute the power into each piece. Okay, why? Because of the plus sign, or even if this has been a minus sign, you can't distribute the power because of the plus or minus sign between them. Those power tricks only worked when things were multiplying and dividing together. Okay, so you can't, this is a totally wrong shortcut. You can't distribute a power over a plus or a minus sign. It cannot be done. You must use either this method or the box method or matrix or whatever you want to call it. Okay, you cannot distribute the power over a plus or a minus sign. Okay, it will fail nearly 99% of the time. So back to this problem. Well, how do I do it? Well, you distribute the power. But why? Because it's multiplication and division. So you can distribute the power to everybody. So this becomes 3 to the third times x to the fifth to the third over 2 to the third times y to the third to the third. Okay? Really important that you understand that those rules that we had for exponents only worked when the stuff inside, the stuff that was being affected by the exponent, was multiplying or dividing. Okay, if the stuff inside was adding and subtracting, you had to find another way. Okay, times this just sits there and goes 10 y squared 21x to the 9, nothing happens. So this becomes 3 to the third is 27, 2 to the third is 8. A power raised to a power, that might be something to put onto a note card prior to the test. Remember we said you can do a brain dump. Okay, that's one of the rules that people get confused on, is x to the fifth to the third, is that x to the 8 or is that x to the 15? Okay, when do you add the powers? When do you multiply the powers? So that might be something to put on a little note card, study it just before you take the test on Thursday, and maybe do a brain dump. Remember I said you can do that onto a blank sheet of paper. Anyway, a power raised to a power, you multiply. 3 times 5 is 15. Y to the 9. This becomes 10. This stays 10y squared over 21x to the 9. Okay. When you put this together, okay, I like to redo it as 25 times 10 over 8 times 21 times x to the 15, I'll get out of the way, y to the second, and x to the 9, y to the 9. Okay. So what I did here, going from this step to this step, is, and you don't have to do this. You could do it all in your head. It's okay.
Wait, isn't it 27 times 10?
Yes, it's 27 times 10. You do have to. See, I'm doing this to make sure you guys are paying attention. Yeah, right. Sure, Foster. Did I screw up anything else? 27, 8, 10, 21. Okay, so I put my numbers with my numbers so that I can reduce them easily, and my x's with my x's and my y's with my y's. I just rearrange them so they're all on top of each other. So if I look at my x's, if I have 15 on top, 9 on bottom, I have x to the 6 on top. Okay, because 15 take away 9 is 6, but I had more on top. My y's, I have y to the 7 on bottom. The only thing that's left for me to do is figure out that. Now, if you have your calculator, it might work it out. Okay, but that might be too big a number. But for example, okay, if we take 27 and call that 3 times 9 times 2 times 5 over 2 times 4 times 3 times 7. Look what I've done. I've taken this. I know that I want to reduce this. So I took 27 is 3 times 9 and 21 is 3 times 7. And I know that these threes are going to cancel out. Guaranteed. I took 10 and broke it as 2 times 5, and 8 is 2 times 4, and I know the two twosies are going to cancel. So now all of a sudden, on top I have 9 times 5, which is 45. On bottom I have 4 times 7, which is 28, and that's my answer. Now, your calculator might have been able to reduce that. 270 over 168. I don't know. I don't even know if mine does. Does it? Let's try it. Turn it on. Clear, clear, quit, clear, clear, clear. Where's my fraction button? Oh, there it is. Fraction, top 270. Bottom 168. Yeah. It reduced it to 45 over 28. So cool. You didn't need to do this, but that's how we used to do it when we didn't have calculators. So yeah, the fraction bar, I just put 270 in the numerator, 168 in the denominator, and it reduced it down to 45 over 28. So cool calculator. So anyway, this was an exponent problem. Okay, this was not an exponent problem. I mean, it was, but okay, they used exponents in two totally different ways. Questions on either of these, before I erase them and do the word problem, not the word problem, the graphing problem. Okay, and we haven't, have we frozen yet? I guess not. All right, can I erase this and put the graph problem up? Anybody gonna yell at me? Okay, so the graph problem, and again, I'm almost certain it was Emma solved by graphing. So we have y equals negative 2/3 x plus 6 and x plus 3y equals 12. Okay, so this, in order to get credit, you've got to graph them. Same thing with the shading problem that we did on last Thursday in class. The only way to do that was to graph the lines and shade the lines. Now, many of you really need to go back and double and triple check how to graph lines, because there was no possible way last Thursday those were parallel lines. It wasn't even close. They were not parallel lines. My answers, okay, were online. What did I say it was? I think I said it was in the chapter 6 module. I think I said that. But anyway, with my work, I showed my work, I showed my graphs, I showed everything. Okay, graphing of straight lines is going to be critical, especially when we do straight lines combined with parabolas or combined with cubics, stuff like that. Weird stuff combined with logarithms and exponentials. Okay, you got to be able to be flexible and do all of them. So anyway, let's take equation 1. Let's call this equation A, and let's call this equation B. So take equation A, y equals negative 2/3 x plus 6. Okay, my y-intercept is 0, 6. My slope is negative 2/3, which is also rise over run. Yay. So I go to my graph and I go to 0, 6. And I go down to run 3. Okay. We're not shading. We don't have to worry about solid and dotted lines or anything like that. Okay. But we do put arrows and we do put the equation. So that's equation A for what it's worth. And I just noticed that it was in slope-intercept form. So I just used the y-intercept and the slope. Taking equation B, okay, x plus 3y equals 12. I see it's not in slope-intercept form, so I personally build a table. If you wanted to move it into slope-intercept form, well, I guess I'll show that in a minute. If x turns out to be 0, y is 4. If x is 0, 3 times y is 12, y is 4. If y is 0, x is 12. Okay, so if we go to 0, 4, 1, 2, 3, 4, 0, 4, and 12, 0. Okay, something like this. Yeah, happens to be like that. I think it's like that, whatever. Whatever. Okay, so this is the line x plus 3y equals 12. Okay, now we've discussed repeatedly why graphing is bad. You still need to know how to do it. Okay, but it's bad for accuracy. It's slow. It's terribly inaccurate. Okay, but I'm still going to ask this on the test. Can you solve by graphing? Can you graph these two lines? Okay, now I think actually, I think it looks more like this. Kind of. Okay, looks more like that for more accuracy. But the key that I want you guys to do is, where is the answer? The answer is where they cross. After you graph the two lines, where do they cross? Okay, again, you can guess. You can say, well, it looks to me like it's 6, 2. Okay, maybe it isn't. That's just a guess. I don't know. Yes. But you can always check your work. You can always check your work by plugging it back into, okay, each equation. If x is 6 comma 2 is 6 plus 3 times 2, does it equal 12? Yes, it does. Okay, plugging it back in here. If y is 2, does it equal negative 2 times 6 over 3 plus 6? So you have negative 12 over 3, so you have negative 4 plus 6. Does it equal 2? Yes. That's how you know you did something right, is by getting that answer and plugging it back into both of those equations. Because literally you're saying that point is on both equations simultaneously. So anyway, I guessed at 6, 2. I checked it when I plugged 6 for x, 2 for y into both equations. I got a true statement. Okay, so then my solution, okay, is the ordered pair 6 comma 2. And again, I will give more credit for graph. And if your graph is a little bit inaccurate, fine, you lose 1 point. Okay, but it's the technique that you're using that I'm more concerned with. All right, I have 3 more problems I want to do tonight. One is long and ugly, okay, and the other 2 are not. So let me put the long ugly one up, and then we'll kind of let you guys work on it and take a break simultaneously. Questions about graphing? Okay, then here's the long ugly. In a right triangle, comma, the hypotenuse is 25 inches. If the longer leg is 17 more than the shorter leg, find the length of the short leg. Okay, before I pause, I want to give everybody a chance to write this down and make sure we're starting with the same drawing. And then we'll pause, take a break, do whatever. Okay, so in a right triangle, the hypotenuse is 25 inches. So right away, I know I have a right triangle, and my hypotenuse, which is opposite the 90-degree angle, is 25 inches. I know that instantly from the first sentence. Sentence has a period in it. Okay. If the longer leg is 17 more than the shorter leg, well, these are 2 legs. Remember, these 2 sides are called legs. Okay. Somebody's short, somebody's long. Okay. X is going to be my short leg. And the other one is 17 more than. Okay. So more than means plus. More than added to. So this has to be X plus 17. So the hypotenuse is 25. The shorter leg has to be an X. Somebody has to be an X. Okay. But the longer leg was related to the shorter leg. The longer leg was 17 more than the shorter. So whatever the shorter was, this is plus 17. So that's how I got an X and an X plus 17. All right, that's my picture. Let's take 7 or 8 minutes. That includes a break, and that includes working on this. And I'll pause this now and get something to drink. Okay, so if this is Pythagoras, then the rule is x squared plus x plus 17 quantity squared equals 25 squared. Now, I haven't made a mistake yet, but I do need to apologize. It's real hard to make these problems up that have nice answers. When we hit chapter 9 and chapter 10, we will do Pythagorean problems some more that have just insanely ugly answers. This is actually a nice problem, believe it or not. And I'll show you how to work through it. And I promise that if there is a Pythagorean one on the test, okay, it will be nicer than this. I promise that. Okay. Now, I'm not sure what's on the mom quiz that's due Wednesday night, tomorrow night, but we'll see. So anyway, that's the formula. It was leg squared plus leg squared equals hypotenuse squared. Now, the first, well, x squared is x squared. The first mistake is when you square that out, you have to remember that that's x plus 17 times x plus 17. That equals 625. So we get up here x squared plus x squared plus 34x plus, what was 17, 289, is that right? 289. 289 equals 625. Okay. So clean it up just a little bit. We have 2x squareds plus 34x plus 289 equals 625. Okay. Again, it must equal 0. You look at this and you go, it's a trinomial. Okay, it's quadratic trinomial. It's got to equal 0. So the first thing I do is take away 625 from both sides. And I end up with, let me grab my notes, 2x squared plus 34x, okay, minus 336 equals 0. Can anybody, since I've been just so red hot tonight and haven't done anything too dumb, can anybody confirm my math to this point?
Yes, correct.
Okay, thank you. Now, the key here is factor, and there's a really good reason why you want to take out the 2 that they have in common. What was that, 190, 168? 168. Okay, for a couple reasons. First off, by dividing the 2 out here, you're working with smaller numbers. Second reason is if you look at this trinomial here, right here that I'm underlining in red, it's what I call an easy trinomial. Now, I screwed up the last example. Let's hope I get this one right. But it's an easy trinomial because it's got a coefficient of 1 in front of the x squared. Okay, so by factoring the 2 out, you go, smaller numbers. And actually, this is a so-called easy trinomial. So maybe life is good. We'll see. However, this is what I was talking about when I was saying ugly numbers. There's no way to get around these ugly numbers. So I'll show you how to deal with it. Okay, and I promise you that nothing will be this ugly on the mom quiz, I don't think, or the test, okay, until we've learned some more skills. But we need, if we do AC is negative 168, okay, you go, how in the heck? I don't know what times what makes 168. I have no clue. Well, you could start taking it apart by, and I happen to see that 8 goes into this 21 times. Because 8 goes into 16, 8 goes into 8. You could divide it down by 2's. It doesn't matter. You can start breaking it down. In fact, I'll do that. If we go, this is 2 times 84. Forget the negative for just a moment. This is 2 times 84. But we can break the 84. Oh, that one is 4 times 21, bring down the 2. I can break this down even further. This is 2. Break the 4 down into 2 times 2. Break the 21 down into 3 times 7. Okay. What I've just shown you is that any way you multiply this together, okay, it will equal 168. That's what this, some of you learned this as a factor tree. You learned to break numbers down into a factor tree. Well, if you take 168 and just start breaking it down, breaking it down, breaking it down, and then take these numbers and put them back together, okay, somehow. For example, what if I took this as 8 times 21? That's going to be 168. But wait a minute, is 8 times 21, is it 17? Is 21 take away 8, 17? No. But you can keep playing with this, okay? All right, 8 times 21 didn't work. What if we did, anybody see how that could go together? What
It's
if I-
7 times 24.
7 times, so, oh yeah, okay, thank you. So if I did that, I'd have 8 times 3, that's 24 times 7. Again, I'm guaranteed that that'll equal 168. But now I need it to equal positive 17 when I add. So if I make it a plus 24 and a minus 7, okay, plus 24 and a minus 7, that'll multiply to make negative 168. That'll add to make the 17. Okay, that was one thing I wanted to show you. Again, don't panic. It won't be, the numbers won't be that ugly. But remember, this is an easy trinomial. So we could 2, and this will break down to x plus 24, x minus 7 equals 0. Okay, I'm right in the glare. So we take this apart and we say, the babies are either 2 equals 0 or x plus 24 equals 0 or x minus 7 equals 0. Remember, the rule was after you factor, you take all of the factors and set them equal 0. Okay, which one of those is utterly stupid?
2 equals 0.
Yeah, and so that's so stupid that some people don't even bother to do it. You just reject it. Don't, or some people don't say, just forget it, I don't need it. Okay, this one solves as x equals negative 24. This one solves as x equals 7. Okay, can I reject any of those and why?
Do the 7.
Negative 24,
Why?
because the measurement can be a negative.
Right. The x
sorry.
in, that's okay, no problems. The x in this problem, it was a word problem, represented the side of a triangle. A length, a side can't be negative. So this is also a reject. So this is our only answer. So we say the short side is 7, what was my units? Inches. Okay. So, couple things I wanted to do here. No, I won't give you anything as ugly as 168 for you to have to factor and break down, but I showed you how to do it without your calculator or with minimal use of your calculator. The other thing I wanted to point out was once you separate it into the babies, okay, some of these are going to reject, but for totally different reasons. 2 can't equal 0. That's just not even in this universe. So that's rejected because it universally dumb. This is a good algebra answer. X equals negative 24. That's an okay answer if this were only an algebra problem. But it's a word problem. And X represents a side, a length, so it has to be positive. That's why that's rejected. And so the only last answer is 7. X was 7. X is our short leg. Okay, anybody start the chapter 7 quiz? It's
I
due
did.
tomorrow.
And
Wasn't there
they're pretty
a,
big numbers.
Huh? They were pretty big. Does this help you figure them
Yeah.
out or not?
Yeah,
Okay.
it does.
Okay, that was kind of my intent. That is why I wanted to get here tonight, because I knew there's a Pythagoras on the quiz like this, and I wanted to give you guys a little bit of chance of getting it right. Okay. All right. I want to do 2 more problems and then we're done for the night. However, we'll come back tomorrow night. I said tonight and tomorrow night are optional. I won't take roll. If you come in tomorrow night, come in with questions. Okay, I don't have anything more to give you after these 2 problems I do tonight. It's your guys' review tomorrow night. So questions that you couldn't get on the quiz. Okay, I'll have some of those, but not too many. Okay, questions from the chapter 1 quiz, the chapter 2 quiz, the chapter 4 quiz, the 5-6 quiz. That's up on Canvas. The answers are up on Canvas. Plus, you can go back and look at them in Mom. Try it again. Can't get new points, but you can redo it. So bring questions. Okay. I gave you some pretty clear examples, at least using words, what's going to be on the test. So if you need clarification, ask me tomorrow night. Yeah, hey, what do you mean by this, problem by these words here under chapter 5 or whatever? And I'll explain it to you. And maybe I can come up with an easy example. I don't know. But tomorrow night is an optional night, fine. But also it's your night to ask any questions on anything. All right, enough preaching. I want to do 2 more problems and then that's the end of it. Unless you want to stick around and ask me questions. Can I erase this Pythagorean problem? Okay. All right, these are both back to chapter 1 and 2. I think chapter 2. I want you to solve. First problem is 2/3 x minus 5/2 equals 5/6 x plus 2. And the second problem is 5 minus 2 absolute value, 3x plus 1, close absolute value, equals -5. Okay, so I'll pause while you guys panic and go through your notes and see if you can do that. Okay, so the first equation was in chapter 2 here. This is where we use the LCD to get rid of fractions in an equation. Okay, and we created something. The LCD was what would cancel all of these denominators. What cancels a 3 and a 2 and a 6 all at the same time? Remember, there's an invisible 1 here, which we don't care about. 6. 6 is the lowest common denominator. You could use 12, you could have used 18, you could have used 24. All of those would still give us the same answer eventually. So then we distributed the LCD here. We're multiplying the LCD to everybody. And if we do, it looks ugly for a moment. 6/1 times 2/3 x minus 6/1 times 5/2 equals 6/1 times 5/6 x plus 6 times the 2. So for a second, it looks really, really ugly. But if you clean this up, 6 times 2 is 12 divided by 3. This becomes 4x. Minus 6 times 5 is 30 divided by 2, 15. Equals, this becomes 5x plus 12. So suddenly, by selecting the correct LCD, the purpose of the LCD, lowest common denominator, sometimes called the LCM, the least common multiple, in our case, is the same thing. The point of it is, if you distribute it to each one of these fractions, it will eventually cancel the denominator. That's all you care about. What number will cancel with a 3, a 2, and a 6? 6. All right, well, now this is easy, okay? I get my x's on one side. This is not, I don't have to set it equal to 0. There's no powers here. The only time you had to set it equal to 0 was like an x squared or something like that. This is just get x all by itself. So if we take 4x away from both sides, we get -15 equals x plus 12. Take away 12 from both sides, we get -27 equals x. If I was a really good student, I'd plug 27 back in here and see if it makes it true. I don't want to do it because I'm also lazy, so that's my solution. I'm done. And the answer is, yeah, there is going to be a problem like that on exam on Thursday. All right. Moving on to problem number 2, an absolute value equation. The game was isolate the absolute value. Get the absolute value alone. Okay. I'm wondering how many people did this as their first step. 5 minus 2 is 3. Absolute value 3x plus 1 equals -5. If you did, you just choked the whole problem. Okay. Think about this for a second. If we had 5 minus 2r equals -5, how would you solve for r? Well, you take 5 away from both sides and you get 2r. -2r equals -10, and then you divide both sides by -2. The point is to get r alone, you got to get rid of the 5 and the 2 in a special way. To get the absolute value alone, you've got to get rid of the 5 and the 2 in a special way. You just can't subtract them. Okay? You have to undo them like we would undo them in an equation. So here's the steps. Okay? First thing, you could take 5 away from both sides. That's going to give me -2. Absolute value 3x plus 1 equals -10. Then we divide both sides by -2. And we get the absolute value of 3x plus 1 equals 5. Okay, it's at this point now that we say the absolute value splits into 2 problems. Okay. If the absolute value equals 5, then this quantity that I just circled could either be -5, because the absolute value -5 is 5, or this could be +5. We don't know. I'm sorry?
I have a question.
Yeah, go ahead.
Why do you subtract 5 from both sides?
Because eventually I want to get the absolute value alone. So I have to take, okay, 5 minus 2a equals -5. How would you solve that problem?
Oh, okay, I see. Never mind.
You take 5 away from both sides, wouldn't you?
Yeah, sorry. I thought you took 5 from the other side.
No, I'm sorry. I took this 5 away. I'm sorry. Okay, so now we say either the thingy inside was worth +5, or the thingy inside was worth -5. We don't know, so we have to worry about both possibilities. Okay, so we solve this, take away 1, divide. Okay, solve this, take away 1, divide, and we have our solution set is 4/3 and -2. So 2 things in this particular problem that I wanted to go over. The most important thing was from here down. An absolute value equation always splits into 2 possibilities. Always, and you have to get both of them. Okay? But absolute value problems, before you start, have to be isolated. You can't split it up here. It won't work. I guarantee you this problem won't. I set it up on purpose. You can't split this up in some strange way and get the right answer. You might get one of them, you won't get the other one. Okay, so you need to isolate the absolute value and then split it up as I've indicated here and get these 2 answers. Now, this just brought to mind a couple of problems that I'm going to do tomorrow night, but I just thought about them just now. So I'm done for the night. If you want to check out, that's cool. If you want to hang around and ask questions, that's cool also. But I'm done. I'll help you if you need me to. Come tomorrow night with questions. As long as you ask questions, I'll answer them. Don't ask questions, we'll say goodnight. All right. Good night. See you later, unless you have questions. I'm going to stop the recording now.